Hello friends, welcome to Python in Shorts. In previous video we saw about the basic of indexes and how these are defined in data frames and series. So let's see how this index values are changing stuffs. But before that we need to understand .loc and .iloc in data frames. So first, starting with .loc method, we can call it as a method used to access group of desired rows or columns in a data frame, basically slicing data frames by applying row level filters based on label or name of the index. This is used with Boolean arrays, which we discussed in a previous video. So let's take one example and try to access one row. Default index .log 2. So now here we are getting a row with index name as 2, that is grapes, number 3 grapes, and price is 15. So here we will only get third row as an output, as we are selecting the row with index name as 2. Let's make a string index to understand it better. Numbers can be a bit confusing in this case, as here 2 does not depict the position, rather than it is considered as the index name. So let's try to use our previous data frame, string index, and here we will try to here we are only getting the rows with index name as BCD. So .loc works with the name of the index. Loc method can also be used with Boolean arrays. Let's see how it does, how we can do it. Let's take custom index .log 1:3. I messed up somewhere. Okay, custom is not having those index name, so we will use our default data frame here. So yeah, it will give me all the values between 1 and 3 index name. Here the two names provided will be included in the output. So we will get 1, 2, 3. That is 1 and 3 will be included in the output. It won't be excluded. So we will get the output as 1, 2 and 3. It can also be used like this line of code. We can create a Boolean array here. False, and we can place it as true and false. So here we are getting first row and second last row, that is apple and mango, like this we can see here. Now it can also be used like placing conditions. So we'll see how it is done. .log, and if I place some condition here, let's say column price greater than 20. Okay, so this returns data frame with records which satisfy above given conditions. Here basically if we see, the inner condition is creating a list of true and false values, which is acting as a Boolean array of same length as of a data frame. We can just execute this statement and see. So this is our Boolean array which was getting created internally, and yeah, this was acting as the Boolean array, and on top of it the data frame was sliced. Now, so to conclude with, till now we saw data frame can be sliced in two ways, using Boolean array, but here we need to make sure Boolean array is of same length of data frame records, and second is using .loc method, where index label or name is used to filter rows. Next we will look dot iloc method. In this, we perform index position based slicing rather than index labels, which we saw in dot lock method. Let's see how it is done. First, we need to create a custom data frame here. Custom index data frame. We have already created it with. Okay, now use. Let's prepare it with set axis. Set axis. Where did we create it? Okay, can take this. We can take this thing. Okay, and if we try to print this now, we will get this data frame. Now if I try to use .iloc and pass one of the index name in this, it will break. Probably it should break, like tff custom index .iloc. Let's say I'm giving it as 67 here. Now probably it should break with the error, means with index error. As the data frame length is less than 67, the line of code fails as it is not able to find the 67th row in data frame, or we can say index is not placed till that position. But if I try to replace this 67 with 3, it will give me the records placed at position 3 in data frame. Let's see it in a picture. Yeah, now if I'm replacing 67 with 3, it will give me the records placed at that position, that is 0, 1, 2 and 3. So the records placed at position 3 is 4, mango and 16, and this is what we are getting here, right? So this is how .iloc is different with .lock method. Now let's take an example to understand this better. We'll create one custom index data frame with some other access value. Let's do it here only, here itself. 1, 2, 1, 3. Okay, we'll delete this cell. Okay, now we have created this custom index data frame. Now here we can see it has duplicate index values, that is this 1, as 1 is repeating 2 times. By executing this code, we can check this with this method dff custom index dot is unique. Okay, it is false. That means we do have duplicate index values. And now let's just try with .log method first, means what we will get by executing this line of code dff custom index .log, and we will try to select 1, 2. So here we are getting 3 rows, 2 rows with the index name as 1, that is apple and mango, or this one apple and mango, and 1 row of index name 2, which is orange, this one. But if we try this with .iloc, we'll see what we will get. Same problem we will try with .iloc method. Okay, so here we will get 2 rows, that is orange and grapes, which is placed at position 1 and 2. Let's see it here. So orange is placed at position 1, that is position 0. This is position 1. Make sure that it is not index name, but it is an index position which is starting from 0. So index position 1, that is orange, and index position 2, that is grapes. So that is the reason why we are getting 2 rows in .iloc method. So this was the main, or I would say important difference between lock and iloc method. Also, I want to show you one more difference which you may face in future. These both methods has bit different impact when trying to extend data frames. Let's understand this, and for that we will take one data frame. Let's look at this data frame, and now we will try to add one more row in it. Let's just try it first with .iloc method. .iloc, we will try to place 0, 1, 2, 3, 4. Okay, so fifth position, and we will add some values. Okay. Now this code fails with reason iloc cannot enlarge its target object. But if we try it with .loc method, same thing. Just replace this thing, and this works. Yeah. So this works fine, and we have new row in our data frame, that is 6 watermelon and 45, which we added just now. So yeah, .loc can also be used to extend the data frames. Okay. So this is all about indexes, and now I want to show why these are very important part of data frame. One thing here, as many of the data frame operations are based on indexes, if we are not taking proper care of indexes in our data frames, then it can break our logics and code in a very bad way. And trust me, many of the times it may lead to logical errors which we may not even come to know, or even if we found the issue, it may take a hell lot of time to debug it. We'll see one small example of this. For that, let's create two data frames. I'll just copy paste it. And here we are creating one data frame with numbers and fruit, and another with some quantity and price values. So now we will try to concatenate two data frame on column level, as we are dealing with y-axis, that is index values for now. So pd.concat df axis equal to 1. Okay, this looks good, but let's mess the index little bit of last data frame. That is this dff v2. For that we can use set axis. We can place like 2, 4, 12, 2, 90. Okay, and now we will run this pd.concat again, and we'll see the result. Okay, now here our data frame breaks. As we can see, our data frame length has been increased now. This much. This can badly mess up my pd.merge or any joining logic if I am having any after this concatenation, as the joining key may have lot of duplicate values, and also this is not the required data frame which I want. Here if we look at the concatenation of the column, that is perfect for the index values which were matching for both the data frames, that is 2 and 4. That 4 is for watermelon and 2 is for grapes, and but for the rest of the rows it is creating duplicate rows with nan values. Let's see how we can prevent or take care of this kind of scenarios. In this, we can always use reset index to fix the messed up index data frame. Like in this case, we can just do this. Here, if I perform reset index, this will make a new column in a data frame index with the existing index values. So these were my existing index values, and new index values will be assigned to data frame starting from 0 to the length of the data frame, means whatever the length of the data frame is minus 1. So here it is 1, 2, 3, 4, 5, 5 minus 1, 4. So 0 to 4 will be assigned. That is a default index. But wait, we don't want this additional column. I just want to get rid of the messed up index. So we can use this reset index with drop equal to true parameter. So we can do it like this, and now I get my desired data frame. We can just do it like this, or we can just use in place equal to true. Okay, and now we will try to run our concatenation thing. Okay, this works fine now. So friends, this was all about the indexes. Please let me know if something was missed or messed up. We can always discuss it. Or if anything more is required, then I can put one more material on this. Keep following for more such in shorts. Thank you.